Hello, this is Tom English again, and this lesson is on factoring. And factoring, unfortunately, is one of the most difficult things in algebra, especially for those students who don't have their basic combinations down. And by that I mean the addition, subtraction, multiplication, division tables, 0 through 10. You should know those combinations as easily as you know your name. But we'll see why they're so important here in this lesson. When we're talking about factoring, we're talking about starting with a quadratic equation, and what we want to do to solve that equation is we want to factor that into two linear algebraic expressions that then we can set equal to 0 and solve for x. And what we really are looking at is the possibilities. What are the combinations in the first and third term that together will equal the middle term? And that's usually the difficulty. For instance, if we look at 4x squared, our choices are kind of small. We only have 1 times 4 and 2 times 2. In the case of 15, again, we're somewhat limited. We have 1 times 15 and 3 times 5. In factoring, what we need to do is look at those combinations and see which ones together will then give us a positive 4 in the middle term. So let's start by drawing a couple sets of parentheses. And 1 times 4, 4 times the 15 is way out of line. 15 minus 4. I don't see those working. So let's start with 2x times 2x. Now the question is, what's the choices for the 15? I mentioned the 15 is too big to work with anything and still end up with a 4. So let's try 3 and 5. Okay, now the fact that that is a negative 15, we know that one of them has to be a positive, the other has to be a negative. So let's just, again, a lot of this is trial and error. Let's start with a positive and a negative here. Now, if you remember your FOIL, how do we multiply these two together? 2 times 2, that's 4x squared. 2x times negative 5, that's a negative 10x. Then the inside, 3 times 2, that's a positive 6x. And finally, positive 3 times a negative 5 is a negative 15. But what's our middle term turn out to be? In this case, it's negative 4x, and this is a positive 4x. We've got the 4x, but we've got the wrong sign. So all we really need to do is change the signs here. Let's make that one negative and this one positive. That would make it a positive 10x and a negative 6x. And sure enough, that's the middle term that we need. Now, these are our factors. What do we do to, again, solve for x? We set those factors equal to 0. 2x minus 3 equals to 0. And 2x plus 5 equal to 0. How do we solve for, well, we first move the 3 over to the other side, then divide by 2, and we're going to get what? X is equal to a positive 3 over 2. In this case, we do this, we move 5 to the other side. That's going to become a negative, though, and we end up with a negative 5 over 2. How do we know that's right? Well, if you'll remember, many times I've said, take the time, put that answer back into the original equation, and see if it works. Let's try 3. We have 4 times 3 over 2 quantity squared, plus 4 times 3 over 2, minus 15. Does that equal to 0? Well, let's see. This squared becomes 9 over 4. The 4's cancel, so that's first term becomes 9. In this case, 2 goes into 4 2 times. 2 times 3 is 6. So we get 9 plus 6 minus 15. Is that equal to 0? Yes, it is. So we know this answer is correct. I won't take the time to put the second one in, but you definitely should do that to be assured that your answers are correct. Let's do one more. Try and make it a little more difficult because not all of them are going to be that easy. Let's try 6x squared. Let's have a middle term of negative 7x, and let's make the number a little bigger. We've got more choices that way. Again, look at the multiples for your first term. 6, what are our possibilities? 1 times 6 and 2 times 3. But with 24, we've got more possibilities, don't we? 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Okay? Looking at those, which ones are going to give us a negative 7 as a middle term? Well, I kind of tell you right now that 24 is too big. Anything we do with 24 in here, we're going to get some pretty big numbers. 2 times 12, that's a possibility. That's 24, 6, that's still pretty big. I would start with the next one down. Let's try 3 times 8. So we'll start with the 6 and let's start with 2x and 3x. Then I suggested we were going to go with 3 and 8. I don't know, let's start with 8 here and 3 here and see what we end up with. Now again, this number, our constant there, is a negative, so we know we have to have one positive and one negative. I don't know, let's try this positive and this negative. What do we get? 2 times 3 is a negative 6. 3 times 8 is a positive 24. No way does that equal 7. So how about, what if we change the signs? Let's make this negative and this positive. We've got a plus 6 now and a negative 24. That doesn't help at all, does it? So that doesn't work. How about, let's go to the 4 and 6. 4 and 6. Well, 2 times 6 is 12. 3 times 4 is 12. They're just going to cancel each other out. Let's go back. That doesn't seem right. Let's try this again. Let's try 3 here and 8 over here. 2x, that's 6x squared. 2 times 8 is 16, and that's a positive 16. X. 3 times 3, that's 9x. Maybe we're getting somewhere here. And 3 times 8, that's minus 24. This, though, again, we've got a positive 16 and a negative 7. That gives us a positive 7x. Just like the last problem, we've got the right numbers, we just got the signs mixed around. So let's just change that to a positive, that to a negative, and we then have our factored equations. But let's look at, again, how do we find the answer? Set each of them equal to 0. 2x plus 3 equals 0. 3x minus 8 equals 0. Let's just do this one. Add 8 to both sides, we get 3x is equal to 8. And we divide by 3, we get x is equal to 8/3. Okay, again, how do we check? Put that back into the original equation. 6 times 8 over 3 squared minus 7 times 8 over 3 minus 24. Is that equal to 0? 2, or this is squared, so this becomes what? 64 over 9. 6 times that. Minus 7 times 8/3. 7 times 8, that's 56 over 3, and minus 24. Oh, we get some big fractions here to work with. I can divide this by 3, and that gives me 2, and this gives me 3. So we now have 164 times 2 is 128 over 3, minus 56 over 3, minus 24. Is that equal to 0? Well, 3 won't go into that evenly, but we can subtract 56 from 128 to 72. So now we've got 72 over 3 minus 24. 3 goes into 72 how many times? Well, 3 goes into 7 2 times. That's 6. Well, look at that. So this becomes 24. This combined becomes 24 minus 24. Aren't we geniuses? Okay, definitely go back and check those answers. Okay, thank you.